We will begin Unit 8 by reviewing exponential functions. We will look at their characteristics and how to graph exponential functions. First, let's recall that we have exponential growth when the value of b is greater than 1. Also, be aware that if your exponent is negative, and when you take the reciprocal of b, if b is then greater than 1, that is still exponential growth. We have exponential decay when the value of b is greater than 0, but less than 1. And again, if you have a negative exponent, and we have to take the reciprocal of b, if b is then between 0 and 1, that will still be exponential decay. So now let's look at these three examples. In number 1, the value of b is 2/3. So that means that we have exponential decay. In number 2, the value of b is 5/4, which means we have exponential growth because the value of b is greater than 1. And in number 3, we have exponential growth as well because the value of b, again, is greater than 1. Now, let me have you try these three problems. Next, we will look at transformations. Please recall H and K from when we were doing transformations with quadratic functions and when we were doing transformations with radical functions. Recall that H gives us a horizontal shift and K gives us a vertical shift. Now let's look at 7, 8, and 9 and tell the transformations that are taking place. In number 7, our K is positive 2, so that is a shift up 2 units. In number 8, we have a shift of down 5 units. And then in number 9, we have a horizontal shift left 1 unit. Now, let me have you try these three. Please describe the transformation. Next, let us talk about the domain and range of exponential functions. For all exponential functions, the domain is all real numbers. You can either write all real numbers or use interval notation. Let's look at the range. When we are finding the range of exponential functions, we have to look at k. If our a value is positive, then our range will be from k to positive infinity. And if the a value is negative, then our range is from negative infinity up to k. Let us identify the domain and range for these three problems. In number 20, our a is negative. So that means that our domain will be all real numbers, of course. But our range will be from negative infinity up to k, which is 4. In number 21, our domain, all real numbers. And our range will be from 0 to positive infinity because our k is 0 and our a is positive. Now, when we look at number 22, our domain, of course, is all real numbers. But to find our range, first of all, our a is positive. So that means that our range will start at our k, which is -1, and go to positive infinity. Now let's talk about asymptotes. An asymptote is a line that a graph approaches but will never touch. When we draw an asymptote on a graph, We indicate an asymptote by using a horizontal line, and it must be dashed. The dashed line lets us know that it is not a part of the graph. And again, our asymptote will always be y equals the value of k. Let us identify the asymptote in the following three problems. In number 13, our asymptote is y equals k, and our k value is 4. In number 14, our k is negative 3, so our asymptote is y equals negative 3. And in number 15, our k value is 0, so our asymptote is y equals 0. Now on to x and y intercepts. Of course, an x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. Also, when we look at increasing and decreasing intervals, we will read the graph from left to right. And when we're looking at increasing and decreasing intervals, remember we must use values from our domain. Within behavior, we are trying to determine what happens to our y values as our x values increase and what happens to our y values as our x values decrease. So now let's practice. Let us look at this function. First of all, the transformation that we have is a reflection over the x-axis. Now, let us state 3 points that lie on the graph. -2 and -0.04 is 1 point that lies on the graph. And I'm just going to write the other 2 below. We have -1 and -0.2. We have 0 and -1. And I'm going to do a couple of more. We have 1 and -5. Now I'm going to graph those points. Next, let us state the domain and range. Of course, our domain is all real numbers. And remember, when we find our range, we need to look for our k, and our k is 0. And we need to check to see if our a is positive or negative. Our a is negative. So our range is from -infinity to 0. Our asymptote is y equals k, so our asymptote is y equals 0. Now, if we look at our graph from left to right and we just trace it, we see that it is decreasing. Our x-intercept, well, we don't have an x-intercept, but we do have a y-intercept at -1. You can either write -1 or you can write 0, -1. Now our end behavior. As our x goes to -infinity, what's happening to f of x? It gets closer to 0. As our x goes to positive infinity, what's happening to f of x? It goes to -infinity. These are all of our characteristics for this graph. Now, you tried this one, so pause the video and then work this out, then start the video again to check your work. Now, check your work to see how well you've done. Now, along the way, you've had opportunities to answer questions throughout the video, and when you come to class, we will answer any other questions that you may have.